Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 5 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have an exponential function here. Now if we look at our reference chart, we're not really going to find a whole lot about exponential functions. We have quadratics, we have linears, we have some properties of exponents, but we don't really have much about exponential functions. So we're going to need to bring that into the STAAR test with us. So let's open up our graph draw feature and let's take a look. What do we know about exponential functions? Alright, so our exponential function is going to have a standard form of this. Y equals a times b to the x power. Now, these terms, the a and the b term, are very helpful in identifying what a graph is going to be. So, let's see what we have here. This a term is going to be multiple things depending on the context. So if you're dealing with investment, savings accounts, compound interest, it's the principal. It's the amount that you initially deposit, and it has interest compounded usually annually. But you could also just say in a more general term, it's the initial or the starting amount. So it could be that we're talking about population growth or bacterial growth. There's always some amount that gets started, and then it increases or decreases at a certain rate, and it wants you to calculate what it would look like in so many years. There's always an initial amount. That's that a term. We can also, for our purposes, since there's no word problem here, so we just have f of x equals 3 times 2/3 of the x. There's no context there. So we also, most helpfully here, can call it our y-intercept. Now, how do we know it's the y-intercept? Well, the y-intercept of any function, right, is where that function crosses the y-axis when x equals 0. So what happens if I were to make my x equals 0? Okay, I'm going to substitute in 0 for the x. Now it's a times b to the 0. Anything to the 0 is simply 1, so it's just a times 1, which means it's just a. So when x equals 0, y becomes a. So now I know that my y-intercept, that's helpful, is 3. So we can easily just take a look at some of our graphs. And look, we're already eliminating a. A is not going to work because that's got a y-intercept of 1. So we've eliminated a. We've eliminated b. Look at that. We've already eliminated 2 answers. Okay, C looks good, D looks good. All right, so we're going to say C is a question mark and D is a question mark, but we've already eliminated 2 simply because of that y-intercept. Now, let's take a look at this B term, because that's also very descriptive for us. This B term is your rate, and it is going to be a growth rate. If it is greater than 1, it is going to be a decay rate if it is less than 1. So this one is less than 1, so it's going to be a decay rate. But we know what these graphs look like. From left to right, a growth rate. And so I'm going to change colors here, draw it over here. So this is what growth looks like. Growth, if I were to put it on a graph, kind of start small, like asymptote over here on the x-axis, and then it increases from left to right. This is a decay rate. That's if it's less than 1. That b term is less than 1. It starts big, but then it brings down, comes down, and asymptote's right there, so it brings down. So we're dealing with a decay rate, which means I need something that looks like this right here. So let's look at our C and D. C, that looks okay. D, look at D. D is our growth rate. So without even graphing it, our answer here is going to be C.